So, we're going to talk... I don't know if I like that either. Black better? Okay. Yes. We're going to talk... This whole chapter is functions. Okay. The big thing of this chapter that you've heard the words in both Algebra 1 and Geometry, but you really haven't done much with it. Our big topic of this chapter is building. That's what's going to drive you crazy here in the next couple of days. Okay, today we just want to talk basics here. I need to teach you how you read that crazy piece of paper I gave you with the brackets, the parentheses, and the U's. What on earth does that mean? Infinity means infinity. Infinity does mean infinity. You're correct. Okay, that is what's called interval notation. And it's a notation you can use to represent a set of numbers that go from this point down the number line to this point. It's telling you it's an interval of numbers that start here and stop here.
So we're not doing any review, are we? We're just hopping in.
Part of this is review. Second part of this is we're going to do a little bit of linear equations, so we're going to know that. Okay, but this actually, I'll tell you, I as a student was always bugged by all the less thans and the greater thans, and okay, was I shading the right way? This is another way to avoid using less thans and greater thans. I wish they taught this way younger to you, because I think for many students this makes more sense than using less than and greater than signs. So let me show you how that works. What does this symbol mean? Okay, so if I graph that on a number line, how do I graph that on a number line?
Shade everything above.
Yeah, so I put 7 on the number line. Y an open circle. No equal sign. So it's an open circle, and we shade to the right. Okay. Interval notation is another way to write that same thing. But what you do is you write down what is the number on the left where this starts, which this is starting at 7. Okay. How far to the right is it going? To infinity. So you go 7 to infinity. Now, you'll notice on that paper, sometimes there's parentheses and sometimes there's brackets.
Yeah, there's a bracket on one side.
Okay? If it's a bracket, it means it can equal that number. If it's a parenthesis, it can't equal the number. So in this case, can we equal 7? No, 7 is open. So which one do I put on the end of 7? Bracket says it's equal to 7. It's closed in. Parentheses. So this a bracket is like a closed. A bracket is a closed circle. This is right in the center. A parenthesis is like an open circle. Okay. Now, the big debate is, what do you put on an infinity?
You put a bracket.
Can you equal infinity? Can you reach an endpoint?
No.
Infinity doesn't terminate, does it? Anything you say where you say infinity is here, I can add one more and tell you a different number. So infinity can never have a bracket because you can't ever find an endpoint on infinity. Infinity always has a parenthesis.
Yeah.
So when you read that, that's saying it's all the numbers from 7 to infinity not equal to 7. The problem is you don't read it like a coordinate. It's not x and y coordinates. It's saying an interval of numbers on the number line. And that's okay. So interpret for me, if I gave you this interval, what would that be on a number line? How would you graph that?
It starts at -6 and it goes to 8.
Yeah, you would only...
And it's equal to 8.
Okay.
But it's not equal to 8.
Yeah, so, okay, in our old system, we would have closed the 8 and opened to the -6.
Yep.
But now here's the beauty of interval notation. This is why I really love it. When we're doing interval notation, we don't do open and closed circles. We actually put the bracket on there and the parenthesis on there because you know it means it doesn't equal -6, but it does equal 8. You can just write right on there. And so when you go to write an answer, you've got the brackets and parentheses right in front of you. So. Oh, yeah, sorry, you should change. Sorry. You should. Okay. Yeah. Okay. In less than greater than notation, how did you write that a set of numbers fell between -6 and 8?
Negative 6 is greater. Less than or negative 6. It's less than 8. Just less than.
When we wrote it in the old style, which is confusing, people always just think, should I use less than, should I use greater than? That's confusing to figure out. Interval notation is so much easier. I'm starting at -6, I'm ending at 8, it's all the numbers in between. It makes way more sense than trying to do that. That's the proper way to write it, but it's confusing to a lot of people. So, I personally am a big fan of interval notation. I would love to.
You're a lazy mathematician.
Yes, I'm a lazy mathematician.
Sometimes it's going to be lazy.
Yeah, because why would you need the other way?
I don't quite understand why we can't teach this at a younger age, why they wait till this. Even algebra 2 you could have taught interval notation.
Yeah.
Yep.
Maybe just in concept of infinity that would scale up.
Yeah, but sort of revolution.
All right, now the other thing Luke noticed about that piece of paper I gave you is sometimes there are U's and there are upside down U's.
Yeah, they're used.
What does that mean?
No idea.
Okay. This is what's known as set notation. U stands for union.
Clearly.
Okay. The upside down U is an intersection.
Okay, I get it now.
Okay, so if I say make a union of two things, what do I want you to do? Combine them. A union means join the two together. An intersection means
It's like where they intersect.
yeah, where they overlap each other, where they cross. Okay. What kind of problems did you do where we worried about whether we were saying it was two separate things that were combined together as an answer, or we worried about where it'd be ands and ors? Remember doing those x is less than 6 and x is greater than 3? Caleb, you did that in algebra 1 too. Okay. So when we use interval notation, instead of using and or, we use union and intersection. You would have seen okay. When we wanted to say if I graph this, if I say 6 and 9, this is saying x is less than 6. Old style, we would have done it that way. X is greater than 9. Okay. But now, if I want to write that in interval notation, how do I write this section here below 6? How do I write that with intervals? What's my leftmost number?
Negative.
Thank you. Negative infinity.
I'm learning that.
And my right-hand number is 6. Okay, since that's open, I use parentheses. Infinity is always a parenthesis. Okay, but then when I want to say it's these answers or it's these up here, we put a U in there for union. So we say it's those unioned with. Now, how do I write this from 9 and up? Parentheses, 9, comma, parentheses. So interval notation is just another way to write the same thing. It's going to make your life a lot easier with what's coming in the next couple of days.
It doesn't make any sense.
It's the same thing you've been doing, it's just a different way to write it. But to me,
I know that clock is not moving fast enough.
Caleb, this is the first day.
I love you,
I visually, in my head, I see a number line. Oh yeah, it's negative infinity to 6. There's a gap. Then there's 9 to infinity. To me, it's more visual. So I'm a big fan. All right, what if I said to you, here's interval notation with,
What's an intersection? Starts at -2 and goes to 5. Everything can equal 5. Yeah. How do you feel about that?
okay, in this case, I want you to find me the intersection. I'm saying, I want you to do an intersection of these two things. If there's an intersection, it means you have to figure out where do they cross.
-1 to 5.
Okay, some of them you can visualize, but it also, if you want to graph it out on a number line,
No thanks.
it works. And once again, the beauty of the interval notation, I know it's a parenthesis to a bracket. And then I know the next one's going to be -1 would be on this side, but above -2. 81's out there.
That's pretty close to 5. Yeah, that's way out there.
I'm sorry, I'm not to scale.
We can tell it's on scale.
Okay. So where are the intersecting?
Between.
Like I said, -1.
Where do you see the two overlapping?
-1 to 5.
Yeah, -1 to 5. There you go. That's. And so then the beauty of using the symbols on your number line is then you know, since this -1 has a parenthesis on it, you know use your parenthesis. If I've got a bracket on it, use the bracket. And you got it in front of you.
See that, Blake? See how she did that?
That's the answer?
That's the answer. This is not difficult, okay? Don't overthink it. It's not.
What are we trying to find? That's just I see now.
This means find the intersection.
Alright.
So we were trying to find where they intersect. They may give you a problem with a U in it, union, so they want you to find what when you join the two sets together, what you get when you do a union, you'll have an answer from here to there when you union them together. That's what they're at. That's all that little piece of paper right here is. All it is unions and intersections, same stuff. Notice I threw you some with ands and ors in them. But I want you to answer me using interval notation. Don't answer me with less than and greater than.
I forgot about hands and orders.
Well, unions are ors, intersections are ands.
That's terrible.
That's all you need to know. Okay. The other thing you're doing today is a topic that you have seen for at least 3 years.
You need to take this off the calculator.
How to put what in the calculator? Numbers?
Or the
What do you mean? How to get to a calculation screen?
We're on there.
We'll learn that later, Dad. Hold on.
It's those assignments. What? Which page? What are you
First
looking at?
assignment. Oh. I got you.
11. What problem are you looking at?
No. No.
Oh, no. Oh, okay. Okay. Do not follow all those instructions that say use the graphical because they want you to plot points and then get connected. I just want you to take any 2 points and just find slow. Mathematics. You don't have the.
Take this fire clock.
Thank you. Thank you.
Minute warning.
That's a good place.